Okay, so now to the calculations part of chapter 4. You've all heard of molar concentrations before. You've all had a chem class before. You've seen that capital M. What is that capital M? What is molarity? And how do you calculate molarity? And then how do you use molarity in problems? Let's first learn the definition of molarity. Molarity, capital M, is moles of solute divided by volume of solution in liters. So if I give you grams of solute, you need to use molar mass to convert the grams to moles. And if I give you volume of the solution in milliliters, you're going to have to convert the milliliters to liters. Once you do that, you put your moles over your liters, you've got the molarity of a solution, which is a concentration unit. You're going to be learning other concentration units later on in the semester, but in chapter 4, it's all about molarity. Okay, so here's a problem. Let's say you're trying to prepare a solution of potassium dichromate, and you weighed out 1.53 grams of potassium dichromate. Again, make sure you know formulas. So this is 1.53 grams of potassium dichromate, and you put it in a volumetric flask, and it was a 50 ml volumetric flask. And then you added the water up until the line, the 50 ml line. So you shook it all up. You know that you have 50 mils of solution total, and you've got this many grams of potassium dichromate. And the question is, what is the molarity? Well, the first thing you have to do is convert your 1.53 grams of K2Cr2O7 potassium dichromate to moles. So 1 mole of K2Cr2O7. You add up all of the molar masses. You've got, hold on a second here. Got potassium is 39.1, multiply that by 2. Chromium is around 52, multiply that by 2. Oxygen is 16, and you have 7 of them. Add it all up, you get 294.2. So 294.2 grams. So the 1 mole of potassium dichromate weighs 294 grams. All right, that way this cancels. And then now we have moles in the numerator. We want liters in the denominator. This is 50 milliliters. To convert it to liters, I'm just going to move the decimal 3 places. So we have 0.0500 liters. 3 places. 1, 2, 3. Okay? You plug it into your calculator. 1.53 divided by 294.2 divided by 0.0500, and you get 0.104 molar to 3 sig figs. Okay? So that's a really simple, straightforward question on how to find molarity. Easy enough. Okay, so now let's learn how to use molarity as a conversion factor. And I always tell students, if you are given molarity in a problem, immediately put units on it of moles per liter. Okay, so for this next problem here, they're telling you that when you go to the hospital and you have an IV, you are given, you know, that physiological saline. That physiological saline is 0.154 molar sodium chloride. That is the molar concentration of the physiological saline. All right, and we want to know how many moles, like they put a bag and it's maybe like a 500 ml bag on your IV. So you want to know how many moles of sodium chloride are in 500 mils of this 0.154 molar sodium chloride solution. So like I said, that IV bag is 500 mils. This is the concentration. You want to know how many moles of sodium chloride that is. All right, so what I was telling you earlier, the minute you see molarity, You change that capital M and you turn it into moles per liter. So it's 1.54 moles of sodium chloride per 1 liter of solution. Okay, so that's what you do immediately when you are given molarity. All right, and then you leave it alone. And then you see what other piece of information they've given you. 500 mils. So we're going to use molarity as a conversion factor to convert between volume and moles. All right, we've been given volumes. We have this as a conversion factor. We're going to end up with moles. The only way to cancel out milliliters is if they're in liters, so that I can cancel it out using this conversion factor. So I'm going to change the 500 mils to 0.5. So 0. See, how many sig figs do they want this 500 mils to be? They want it to be 3 sig figs. So they want these two zeros to be significant. So I'm going to say 0.500 liters of solution. Moving the decimal 3 places, 1, 2, 3. 0.500 liters of solution. I'm going to take my molarity as a conversion factor. All right, 0.154 moles of sodium chloride per 1 liter of solution. Get my calculator. All right, and you've got 0.5 times 0.154, and you get 0.0770 moles. So 0.0770 moles of sodium chloride. Okay, so that answers part of the question. The other part of the question, I think, was how many grams of sodium chloride are in the 500 mils? All right, easy enough. All you have to do now is do a molar mass to convert your moles to grams. So we're going to write 0.770 moles of sodium chloride. And molar mass of sodium chloride, 1 mole of sodium chloride. Sodium is 23. Chlorine is 35.5. One of the few ones I have memorized. This is a 5. Doesn't look like a 5, but it is. All right, so we do the math. 0.0. Oops, see, this is really bad. There you go. That's better. I caught myself. 0.0770. Don't do those types of mistakes, okay? So be really, really careful. When you're copying a number, copy it correctly. All right, so take that times 58.5, and you get with 4.50 grams, rounded correctly. So 4.50 grams. So in every half-liter bag that they give you of physiological saline, if you're in the hospital, you are getting 4.5 grams of sodium chloride. Okay, so that's that question, and that deals with number 10 on the what you need to know list, where it says be able to calculate molar concentrations and use molarity as a conversion factor. So this one is using molarity as a conversion factor, and we already know how to calculate molar concentrations. Okay, so now we're going to do the next thing, and that is dilution. Dilution, if you are given a concentrated solution, it always has a higher concentration than a diluted solution. So usually what you'll do is you'll add solvent to something and you'll turn it more dilute. The number of moles are still the same in both solutions, but usually the volume is just more. If you're starting off with something and then making it more dilute, you're just adding more solvent to it. So let me just show you the basics for dilution. And normally we just go M1V1 equals to M2V2. Please, 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 I beg of you, don't ever, ever, ever use M1V1 equals M2V2 for anything except for dilution. So this is only to be used for dilution problems. Never, ever, ever to be used for titration problems. never to be used for any of the volumetric stoichiometry problems, only for dilution. What is M1? This is initial molarity. V1 is initial volume. What is M2? This is final molarity. What is V2? That's final volume. Okay, so here's the problem. We have a stock solution of sodium chloride, and that it is 6 molar. All right, so your initial molarity is 6 molar sodium chloride. And you want to turn it into physiological saline. So all you budding pharmacists out there, when you're working in the hospital, you don't get physiological saline automatically sent to you, or maybe you do, I don't know, that seems too easy. They give you a stock solution of 6 molar sodium chloride, and then you have to dilute it to make it 0.154 molar. So your final molarity, you want it to be 0.154 molar sodium chloride, because that's your physiological saline. All right, and you want a liter of that. You want a liter. All right, so the question is, how much of this do you need to take out and put in a volumetric flask and fill it up with water to a liter in order to get this molarity? All right, so the question states, a saturated stock solution of sodium chloride is 6.00 molar. How much of this stock solution is needed to prepare 1 liter, 1.00 liters of physiological saline solution, which is 0.154 molar sodium chloride? Okay, so our unknown is the V2. It's just now a matter of plug and chug. So 6.00 here. This is my X. This one over here is 0.154, and this is 1 liter. Okay, let's plug it in. 0.154 divided by 6 is equal to 0.257 liters. See, I'm forgetting the zeros. This is really bad. 0.0257 liters, which is 25.7 milliliters. Okay, so you need to take out 25.7 milliliters of this 6 molar solution, put it in a volumetric flask, add water till you get to 1 liter, and then you've got your 1 liter of physiological saline. Okay, what if the question asked, how much water must you add to this? So you know that you need to take 25.7 milliliters. So how much water are you going to add? Well, you want it to be a whole liter, which is 1,000 mils, and minus 25.7 mils. So basically, you're going to need 974.3 milliliters. Since we're rounding over here, this is probably 974 milliliters of water are going to have to be added in to the 25.7 milliliters of the 6 molar in order to end up with a liter of this. Be careful, because it gets a little tricky sometimes in the homework and on the test, where they're not looking for V2 or V1 or V2. This, by the way, should be V1 here. They're not looking for those. They're looking for how much water. So you're going to have to do the M1 V1 equals to M2 V2, and then you're going to still do a subtraction to figure out how much water do you need to add. Okay? All right, good. In the next video, we will do gravimetric analysis, and then we will also do titration and solution stoichiometry.